Use the vertex hk and a point on the graph xy to find the standard form of the equation of this quadratic function. Well, the standard form for a quadratic would look like f of x equals a times the quantity x minus h squared plus k. The nice thing about this is the vertex is located at the coordinates hk. And if you happen to know those particular coordinates, you really can just plug those right into the equation. So we get most of the equation just because we know what the vertex itself is. So already we can say our equation for this quadratic is f of x equals a times x minus 2 quantity squared plus 1. Notice this became a negative 2 because there's a minus in front of the h value. So it just changes sign. Now this other point, I have xy equals 3, 2. Well, one thing that I know about a function is f of x is the definition of the y variable. So I can actually take a coordinate pair, which is xy, and plug into this equation. What it would look like, so the y value is 2, and then I have equals a times the x coordinate of this point is 3, then minus 2 quantity squared plus 1. Now, the only variable remaining is just a, and that's the only thing that we have left that we need to solve for. So let's see what can happen here. 2 equals a times 3 minus 2 is 1, and 1 squared is 1, so this is just a times 1, plus 1. If I subtract 1 from both sides, that will cancel it out here, leaving me with a equals 1. So my final answer here is f of x equals 1 times the quantity x minus 2 squared plus 1. And this is a quadratic function that will pass through these 2 points, and this particular point being its vertex. You could graph it and double check, but it will certainly work out that way.